Hi, and welcome to Digital Scan 3D. My name is Sam, and today we're going to look at the Artec Ray, a long-range 3D scanner from Artec. Today we're going to look at an application of us scanning a bridge. Let's get to it. I'll meet you outside. The Artec Ray is an excellent option for scanning long-distance objects, scanning bridges, buildings, cars, utility poles, anything that has a long distance that you need to stay accurate along the entire length of it. Let's go ahead and demonstrate it right now. So the Artec Ray has two color cameras that you can then apply color texture to your spherical 3D scan. In the center there you have a spinning mirror apparatus for the laser to capture in a nice arc. There's an onboard battery that you can swap out for extended scanning, and you're not limited to one charge time. The Artec Ray has a SD card slot, which allows for quick swapping to help extend your memory storage. The Artec Ray scans 360 degrees with a 270-degree arc. It scans sub-millimeter accuracy, even up to 100 meters. The Artec Ray is not only versatile, but you're not tied down to any one location. As you can see, we don't have any cords. It's all battery operated and run from a mobile app. So now that we've completed one scan, we're going to go ahead and move the Artec Ray and perform a secondary scan. Now, the purposes of the secondary scan are both to flush out and fill in our resulting scan and add in some redundancy in some of the points. To showcase the mobile app here, we've moved our ray to a position that we're going to scan in, and let's go ahead and perform a quick preview. So we're going to go ahead and press the preview at the bottom of the app here. Now with our preview done, we're going to jump back to our main window, and let's go ahead and just target our bridge here. And zoom in and do a box selection. Now the scanner is going to move and just capture the area of interest. The environmental factors can play a significant role in increasing or decreasing the accuracy of your 3D scan. So for instance, our bridge, we were scanning our bridge and we are not sure now. We have no guarantee that the bridge is now perfectly stationary. It could have shifted with the weight of the train cars, and maybe the scanner's sub-millimeter accuracy. With that type of deviation, any type of alignment can be affected. Now that we've finished scanning with the ray, we're going to go ahead and pack it up and pull out our Leo. The purposes of doing that is that the Leo can capture really high resolution and really high accuracy in very small areas that maybe are some points of interest that we can then capture on the bridge. So let's say like our points of interest are going to be the steel cross member above us, as well as these posts that are holding all the bridge up. Maybe we want to get a little bit more information about how it's mounted and some of the bolt locations. Now that we've captured our supplementary data, let's go ahead and head to the office and combine the data. All right, we're back from that. Let's go ahead and grab our data and send it to the computer. So we'll go over to our little window over here and pop out our SD card. So I'm going to go up to File, go to Import, Scans, Meshes, or Point Clouds, as we're just importing in the raw Artec Ray files. And here we're going to go up into the folder that has our C3D files, which if we look at the formats, the Artec Ray raw scan formats are the C3D files. So I'm going to just grab, box select all of them, like this, and say open. Now we didn't have any type of alignment features or anything like that. We're going to do all alignment within Artec Studio. So I'm going to just say no. Alright, and now that we have our scans imported, I'm going to go ahead and preview them here. I'm going to go ahead and zoom out. And let's go ahead and switch to our scan colors. So here, since we've captured in a sphere, as you can see, and we see the bottom half of the sphere as well, and that's mostly due to the fact that there's a little bit of noise or reflective surfaces on the ground where we were scanning. We can easily just chalk that up to just some noise. Everything of interest is in this portion right here. Alright, let's go ahead and align these files. So we're going to go into Align. We're going to lock one of them, this one right here, and here we can see our bridge is right there. So I'll go ahead and turn on the second one, and bring this one over a little bit, and choose some common data here. That's a good third spot to align to. And when we're aligning, we were kind of looking for 3 points that match up, or at least that are common to each other. So let's go ahead and go back to our editor, eraser, and now that everything is kind of a little bit better in terms of what we are looking at here, we can select just the bridge, and I'm going to choose this telephone pole since it's a nice third point to align to. And I'm going to go ahead and inverse and erase. Now let's go ahead and import the Leo data. I'm going to turn on the Leo Scan 1, and then go to Align, lock all the race data, and pick some common points. I'm just going to go ahead and do a Sharp Fusion now. I'll leave the settings the same. Now that the Sharp Fusion has finished for the ray triangulation method, we can inspect it. For the purposes of this demo, I'm going to be using the ray triangulation method. I'm going to go ahead and turn on my both Leo datas, and I'm going to turn off the ray scan because it's just a big file. Since the ray's already processed a resolution of 3 millimeters, we're going to leave the Leo scans to be processed at like 1 millimeter. Whole fill radius, I'm going to set that as 15, and I'm going to say apply. Alright, so now that the mesh is finished for the Leo, just a quick glance at it, looks like everything is processed correctly. And at this point, we're ready to bring it into our inspection software. We're going to use Control X. So let's go ahead and export out these scan data and jump over there. So now we have our bridge here in Control X. Now let's go ahead and save before we get too far along. Now let's go ahead and align our scans. As you see, the origin is not where we want it. It would be nice to have it on a origin of some sort. Let's go ahead and do that. Let's go to our Home tab. Let's go ahead and create planes, construct a geometry. Make sure we don't quit command with OK. This will allow us to continually create planes without having to reopen the command every single time. Go ahead and create a floor plane, which I'm going to use the road for. Once I'm satisfied, I can go ahead and preview the plane. As you can see here, it looks about right. I'm going to go ahead and accept it. And since I had the don't quit command turned on, I can go ahead and create my next plane. Now the center pillar here in the middle of the road would be a good middle plane here. So let's go ahead and create two planes that we can then extract the average plane of the two. that we can then use as our center plane. Now we can switch our method from definition to average. And we can select our plane 2 and plane 3. And it'll give us this orange plane here, which is our average. And say OK to accept it. Now for our front plane here, you notice the bridge is not perpendicular to the road. Let's go ahead and use the front face of this beam. I'm going to go ahead and switch back to definition and paint in the front of this beam here. And switch to extract. Go ahead and preview it. Looks about right. Accept. And with that, we have 3 planes which we can define our X, Y, Z directions with, as well as choosing the intersection of them for our origin point. Let's go ahead under measured and transform the measured data. Let's make sure to select both our scan data. Select geometry to move. We're going to select all of the geometry. Now let's go ahead and go to the next stage, where we're going to select interactive and line. We're going to switch to XYZ. For position, we're going to go ahead and select plane 1, plane 4, and plane 5. For our x-axis, we're going to go ahead and select, I want to select this plane right here. Make sure we select it off the paint tool. And let's choose the floor as our y-plane for our y-axis. So once you have y-axis selected, I'm going to go ahead and choose plane 1. And this looks like it's properly aligned now. If we switch to front view, we can see it's properly aligned. Now that we're there, we can say OK. Let's kind of make a plan of what we want to inspect here. If you were interested to know what the angle is of the train track relative to the front of face of this beam, or our center beam here, let's go ahead and extract that plane. And once I've selected the data, I can go ahead and preview. Looks correct. Let's say OK. Now maybe I'm also interested in checking out this beam here. Jump over to the Leo data. See, there's a nice little bump there. Now the posted sign says that this bridge is 8 feet and 6 inches tall, or at least the clearance is. That's a pretty short bridge. Let's go ahead and check just how accurate that claim is. We go ahead and plane right there. And this plane will go across the entire length of this beam. We're just going to go ahead and create a plane using the 4 corners of this beam here. This will give us the average. The average of the point selected. There we go. I'll say OK. And since we turned off the planes, let's go ahead and turn that back on. Looks right. See, it's this one right here. Looks about right. Let's see, another interesting thing to look at. maybe we're interested in seeing just what angle these posts are at. Let's go ahead and get out of our add plane and switch to cylinder. Now we go to method extract. Looks about right. We're going to go and exit out cylinders. Okay, now that we've finished putting in the cylinders and setting up with the planes and so forth, let's go ahead and check out this dimension here. Now the postage signage says it's 8.5 feet. So let's go ahead and grab a linear dimension in our dimensions tab. Linear dimension. Grab our plane 7 here and our plane 10. So 8.5 is going to be 200 or 2,000, I should say, 2,109 millimeters as our reference value. And let's go ahead and throw in a tolerance of 50 millimeters. Now that's about 2 inches. And like I said, our tolerance is going to be pretty loose. Yeah. And with that, let's go ahead and generate a report. Jumping over to Home tab, press Generate Report. And here I have a template that I made for, let's go ahead and it's portrait. Yeah, portrait. Let's do portrait. Now we have our reference data, mixed data, plane group. We don't really care about re-showing all that. I'm going to turn those off. We just have our front, top, and side views. And partly is train bridge. And go ahead and say generate. And spit out the PDF. And here we have a nice concise report. We have the front view image here. We have the perpendicularity, our top view, side view. For those who have questions about the Artec Ray or are interested in purchasing one, feel free to reach out and give us a call, and we'll be happy to answer your questions. We also offer a variety of 3D solutions, such as 3D scanning, reverse engineering, quality assurance, 3D printing, and even reselling basically any type of product we work with, such as 3D scanners. Once again, my name is Sam. Thanks for watching, and take care.